So when we have multiple random variables in play, what's going to happen here is we're going to have to account for the combination by either adding or subtracting the mean, depending on what we want to do with the variables. So if I take two random variables and I add them together, then the mean for that sum would be equal to the sum of the means. Okay, so what's going to happen is we're going to take multiple variables. We're either going to add them together, look for totals. We might subtract them, look for differences. And so much like yesterday, when we attack the mean for a problem like that, the mean is going to do exactly what we expect. If we add the variables together, then I'm going to take the original means and I'm going to add them together. If I'm going to subtract the variables, then the means are going to subtract as well. And again, knowing both notations, so either the e of x, e of y notation, or the mu of x, mu of y. But the mean does exactly what we expect, just like yesterday. The standard deviation, though, is quite a bit different here. So first of all, it's important to note as you're writing this down, the variables in question, when I go to attack standard deviation, must be independent from one another. The means will combine no matter what. If I have two variables that I want to add or I have two variables that I want to subtract, I can combine the means no problem no matter what. But if I want to combine standard deviations, the variables themselves must be independent from one another. So one cannot affect the other. And then the other thing to note is when we calculate standard deviation, and this is why I kind of brought it up yesterday when we were talking about those formulas, is this time when we combine these random variables, standard deviations do not combine. So the means combine like we would expect. I add the variables, I add the means, subtract the variables, subtract the means, but standard deviations do not directly combine. The variances are what combine when we have these random variables. So I have to convert my standard deviations into variance. And then the other thing is when we're looking at this here, whether I add or subtract, my variances always add. So the means will add or subtract according to what I do with the variables. The variances will always add. And so what that would look like is if I wanted to do the standard deviation. So this is giving us the variance formula. The variances combine directly. But if I'm going to calculate standard deviation for a combination of variables, so standard deviation is the square root of variance. That means we would take the standard deviation of x squared plus the standard deviation of y squared, add those two together, and then take the square root to convert it back to standard deviation. So with linear transformations, the variance wasn't that important of a topic because we had a direct change associated with mean and standard deviation. But with a combination of variables, standard deviations don't combine directly. So I have to understand how to convert to variance, and then I combine the variances together always through summation, and then I can convert back to standard deviation. The other thing to note here is when we combine random variables, there's times where we might combine a variable with itself. So for instance, x1 plus x2. This is one, if you think about the worksheet from Friday, when they were talking about like insurance policies and how insurance companies got away with giving away so much money on policies. Okay, what's happening is when we calculate the values for multiple individuals, we're adding the same random variable together over and over again. So every time they insure a new individual, we add a new random variable to the mix. So we're adding the same random variable to itself over and over again. Now in algebra, when I take 1x plus another x, we can just combine that and say that's the same as 2 times x. With random variables, that does not apply. If I take 1x plus the other x, it does not equal 2x. On the left side, x plus x is a combination of variables. On the right side, 2x is a linear transformation. And the formulas are not the same. When I do a linear transformation, if I want to calculate mean, I take 2 times the mean of x. If I want standard deviation, I take 2 times the standard deviation of x. So if I'm looking at that right side there, my formula for the mean of 2x is taking 2 times the original mean of x. When I calculate standard deviation of 2x, I'm taking 2 times the standard deviation of x. That's what my linear transformation formulas tell me to do. On the left side, though, if I'm doing the mean of x1 plus x2, I'm taking the mean of x plus the mean of x. The means do end up being the same, but it's the standard deviation that's the problem. When I go to calculate standard deviation, the standard deviations do not combine directly. When I combine random variables, when I take 1x plus another x, the standard deviations don't add together, the variances do. So what's going to happen here is I'm going to have the variance of x plus the variance of x, which if I simplify would end up being the square root of 2 times the standard deviation of x. When I add those together, I get 2 variances of x. Square root of variance is standard deviation. But I do not have the same coefficient in my final value. So when we're combining random variables, if we're combining the same random variable together, we cannot treat it algebraically like we normally would. X plus x does not equal 2x. One's a combination, one's a linear transformation. The formulas are different. So that's the other thing when you're reading through these problems and you're trying to decide what formulas to work with. You need to make sure you pay close attention to, am I combining random variables? Am I adding variables together? Or am I multiplying my variable by a value? Because the functions we use, the formulas we use, are different for each process. Okay? And if you want a further explanation on that or see it kind of a little bit more fully explained, page 409 in your book kind of goes through this idea of the x plus x not equaling the 2x. So you guys can take a look at that on your own time there. So now if we put this into practice here, so yesterday we talked about Pete's Jeep tours. We did some different different transformations. So now Pete's sister Erin, who lives near a tourist area in another part of the country, is impressed by the success of Pete's business. So she decides to run tours on the same days as Pete in her slightly smaller vehicle. So she discovers that the number of passengers, and we define her variable as y, on her tours follows the given probability distribution in orange. So she's going to give tours exactly like Pete does. Her car is a little bit smaller. She can only hold up to 5 passengers at a time. And then again, based on empirical information, she creates the probability distribution there in orange. So yesterday we talked about, for Pete, his mean number of passengers, so how many he expects to have on average, would be 3.75, standard deviation of 1.09. Erin's expected value would be 3.1 passengers with a standard deviation of 0.943, and those are both found using the general formulas from last week. So now what we want to do is we want to calculate how many total passengers Pete and Erin would have on their tours on a randomly selected day. So the first thing we'd have to do in a situation like this is we'd have to start by defining our random variable t. So to calculate the total number of passengers they should expect, what would I be doing here? How do I define t using the given random variables? Do what?
Would you add the 5 plus 6 passengers?
We don't want to talk about specific values yet. Just in general, if I want to define t, how do I define t using the 2 variables we've already defined? How would I calculate the total number of passengers on a given day? I would take x plus y. I take Pete's number of passengers plus Erin's number of passengers, right? So the first thing I have to understand is what exactly am I doing with these variables? So in this case, we're adding the variables together. We're taking the number of passengers Pete has on a given day plus the number of passengers Erin has on a given day. So when I add my variables together, if I want to calculate the mean total, the formula said take the mean of x plus the mean of y. Just do exactly what we expect. So I'm going to take the 3.75 plus the 3.10. And on any given day, Pete and Erin should expect to have a total of 6.85 passengers on average. So over numerous randomly selected days, the average total number of passengers should be about 6.85. Okay. When we go to calculate standard deviation, so first of all, if I want to calculate standard deviation, do my standard deviations combine directly? Can I just take the 1.09 plus the 0.943 like we did with the means? No. What actually combines? The variances. So the first thing I have to understand here is I need to convert my standard deviations into variance. But before I even start to attack that, what do I have to justify first? that they're independent. I don't want to start calculating standard deviation until I've verified that my two variables are actually independent from one another. So when we look at the description here, it said Aaron lives in a tourist area in another part of the country. So would Aaron running her tours in one part of the country affect Pete running his tours in another part of the country? No. They're not going to have an effect on one another, so it is reasonable to assume these are independent. Now, if Pete and Aaron lived in the same city, so if they were both living in the same city, both running Jeep tours, would one affect the other? Yes, then one probably is affecting the other. If one's getting more tourists, the other one's probably not getting as many, so it's going to affect it there, okay? So that's kind of what we're talking about when we're looking at that independence. We have to verify, or we have to assume that it's reasonable for the the variables to be independent of one another. So now that we've assumed that, now that we've justified that, we can go ahead and make our calculations. So we take the standard deviation from Pete and square it. Take the standard deviation from Aaron, square it. We're going to add those together, then take the square root. And you guys are going to use your calculators here. Plug that in. And what do we get for a standard deviation? .44. Everybody getting that? Okay. So about 1.44 passengers. So on any given day, over many randomly selected days, they should expect a total of 6.85 passengers on average. Over many randomly selected days, a given day total will typically differ from that mean of 6.85 by about 1.44 passengers. So knowing how to calculate and also interpret, just like we've been doing the last couple days. Okay. Now, if I were to change this problem to calculating the difference. So if I want to say, or if I said I want to find the difference in the number of passengers that Pete and Aaron should expect, what's going to happen with my mean? Yeah, we're going to subtract instead of add. So we're going to take the 3.75 minus the 3.1. They should expect a difference of 0.65 passengers. So on any given day, Pete should expect 0.65 more passengers than Aaron. What about my standard deviation? It's not going to change. My standard deviation for the difference is exactly the same as the standard deviation for the sum. So whether I add the variables or I subtract the variables, the variances always add. So changing to the difference would affect the mean, but it's not going to affect the standard deviation. I would still get the 1.44 passengers because we always add the variances together. Okay. So then the next one here. So college uses SAT scores as one criterion for admission. Experience has shown that the distribution of SAT scores among its entire population is such that the SAT math score, which they're defining as random variable x, mean and standard deviation given there, and the SAT critical reading score y, mean and standard deviation given there. So it says, what are the mean and standard deviation of the total score, x plus y, for a randomly selected applicant to this college? So if I were to select an individual randomly, and and I did this over and over again, what would the mean score that we expect to see be on average? And what would the standard deviation be? So if I wanted to calculate the mean in this setting, what would I do? I would add the means together. I would take the 519 plus the 507. So my mean for random variable x plus y would be the mean of x plus the mean of y. What about standard deviation? What would I do?
You would change it
So we would change the standard deviations to variance, add them together and take the square root. But what do I have to do first? I have to check if they're independent. When I select a random student, is their score on the math test going to be independent of the score on their reading test? And in this case, they're not independent. Kids who tend to do better on one part of the test tend to also do better on the other part of the test. Kids who tend to do worse on one part tend to do worse on the other as well. So in this case, one score does affect the other. So because they're not independent, we cannot calculate the standard deviation for this combination. That would require a process that's above what we need to do for this class. So when you're doing these problems in the homework, when you're doing this on a test or a quiz, the means will combine exactly like we expect every time, no matter what. But I have to remember to check that independence condition before I start to calculate standard deviation. So they will not combine unless they're independent. Okay? Last one here. So this is kind of like what you'll see in the homework. This is a problem from the book. So El Dorado Community College has a main campus and a rural campus. The amount spent on tuition by a randomly selected full-time student at the main campus, they're defining as random variable m, follows a distribution with the given mean and standard deviation. The amount spent on tuition by a randomly selected full-time student at the rural campus, random variable r, follows a distribution with the given mean and standard deviation. What they want us to do is take the combination of the variables. They want us to calculate the difference in tuition between the main campus and the rural campus. So the first part of the question says calculate and interpret the mean of D. So if D is defined as the amount of tuition for M, the main campus, minus the amount of tuition for the rural campus R, what am I going to do with the means? Subtract. So I'm going to take the mean from the main campus minus the mean from the rural campus. So if you plug that in your calculator real quick, what do we get as a difference? 92.5?
Yeah.
Okay. So we get a mean difference of negative $92.50. Now, when we calculate this, is it okay to have a negative value here? Yeah, since it's a difference, this is an average difference, right? It's okay to have negative values, even in a situation where negatives wouldn't necessarily make sense. Since we're calculating the difference between two random variables, the difference can be negative, and it's an average value over numerous trials. So what this means is if we were to select multiple individuals from the main campus and multiple individuals from the rural campus, and I were to subtract the amount of tuition that they pay, on average, we would expect the rural person to spend $92.50 more than the main campus person. So if I were to select individuals from both over and over again and calculate the differences in the tuition that they pay, on average, we would expect to see the rural campus person spending $92.50 more. So in the next part, explain why it's reasonable to view M and R as independent random variables. So this kind of goes back to the Jeep Tours example, right? If we've got the main campus and the rural campus, would what one student at the main campus pays for tuition affect what the student at the rural campus would pay? No, one is not going to have a direct effect on the other, so it's reasonable to assume that these are independent. And because of that, we can then calculate the standard deviation. So if I want the standard deviation for the difference, we're going to take the variance for the main campus plus the variance for the rural campus. Again, even though we're subtracting the variables, we're adding the variances together. So we would take the 102.8 squared plus the 126.5 squared. And then whatever that comes out to be. And then when we interpret, if we were to select multiple individuals from the main and the rural campus and calculate the difference we calculate will typically differ from the mean difference by about whatever this comes out as. So again, that standard deviation is that typical distance from the mean. Last thing, linear combinations. So now this last little bit here takes yesterday's and today's and puts them together. So when I take a linear transformation and I combine random variables, knowing how to attack it. So in a linear combination, if I multiply my variables by a constant, so that's the a times x, b times y, I could be multiplying one or both. So it doesn't have to be both are being multiplied by a constant, only one could be. But if I'm multiplying by a constant and then adding the variables together, the means are going to do exactly what you expect. You're going to multiply the mean of x, multiply the mean of y by their constants, and then add them together. But this is where that standard deviation gets a little trickier. So assuming that the variables are independent, and that is still crucial, even with the linear transformation in play, we're still combining random variables, which means that independence assumption needs to be met. But then we're adding the variances together. And so yesterday we talked about when we calculate variance with a linear transformation, when we multiply or divide by a constant, the variance gets multiplied by that constant squared. Now, the other thing to consider here, if I wanted to, I could do this in a little bit different order of operations, where if I know I'm taking a times x, we know that the mean becomes a times the mean of x And if we remember from yesterday, that means that the standard deviation also gets multiplied by that same constant. So what I could do here is I could, for this standard deviation calculation, I could take A times my standard deviation of x first, and then square it, and then take B times the standard deviation of y, and then square it, and then combine them. Or I can remember the new formula. So I can do the multiplication first, convert to the new standard deviation, and then take that new standard deviation and square it. Or I can do it all in one step where I just multiply the variance by the value squared. Both will end up at the same value. And then obviously if we're doing subtraction, the means would subtract, but the variances would still add. Okay. So here are the problems then I want you to try out.